Hello everyone. Now in this video, we're going to be looking at the idea of complementary events. And before we even get into this, I want us together to make some observations about probabilities, about the different probabilities we see in the world around us. So you may see here, I have my die that I've drawn in my previous video. And we're going to be looking at this for reference in this video. Now, we said before that, well, the probability of any of these numbers being rolled is going to be the event of one happening out of a possible 6 events. So my probability of rolling a 1, for example, will be 1 over 6. This probability being a fraction of a whole, and the whole being every single event, right? And let's keep going here. So we have, for a probability of rolling a 2 would also be a 1 over 6. And so on and so forth. We eventually get that every single one of these will give us a probability of 1 over 6. Now, 5 and 6 will also give us 1 over 6. So just to save some time, I won't write all of these out, but you can see the trend happening, right? Now, what would all of these probabilities sum up to? So if we were to take each probability, right, and add it together, what number would that sum up to? Now have a moment, and you may be able to think of this and also intuitively kind of get there, but let's slowly run through it. So the kind of total probability, if we were to sum this up, we would get a sixth plus a sixth plus a sixth plus a sixth and one more plus 1/6. Now, adding up all of our fractions, we are going to be left with, and if you need a little refresher, I have a video on adding and subtracting fractions, but we will get a total of 6 over 6. And this can just be simplified to, well, 1. Now, what is the significance of this 1? And what is the significance of adding up all of our total, or the total of all of our probabilities? Well, all of our probabilities summed gives us every single possibility. And that is my 1 here. This 1 tells us that with absolute certainty, I can say that if I roll a 6-sided die, I will get a number which is 1, 2, 3, 4, 5, or 6. This idea of 1 is my certainty. That's my probability that I know for certain that I'm going to get it, that I'm going to get one of these things. Same with a coin flip. I know for certainty that if I flip a coin, I will get a head or a tail. So if I were to say, well, what's the probability of getting a head or a tail? Well, you would say, well, it's certain. It's just 1. And the same thing goes with an impossible probability. So say I was to say, well, what is the probability of rolling a 7 on a 6-sided die? Well, 0, right? So each probability will lie between 0 and 1. And that makes sense because we are looking at fractions. Our probabilities are fractions of every possible event. So it makes sense that they would range from 0 to 1, because 0 to 1 can be a multitude of different fractions. So this is very powerful, right? Because it brings us to this idea of complementary probabilities. This idea that if we know one probability, it can tell us about other possibilities, right? So let me explain. Let's go back to my die and let's say I want to find out, well, what is my probability of rolling a 1? Well, we said before that this is 1 over 6. Now, a complementary probability is essentially everything that is not that. And you may be thinking, if you've watched some of my other videos, especially in angle geometry, I used this word complementary before, didn't I? I talked about, well, complementary angles, where I said that, well, if I draw a line through some right angle, then this angle and this angle would add up to 90. And whatever, if I was given one angle, I could find out what the other is by knowing this angle's relationship to my 90 degrees. Well, I'd say this angle is just the difference between 90 degrees and my known angle. And that is the exact same thing that's happening when we look at complementary probabilities. Because I can say, well, what is my probability of it not being 1? Well, I could count them, couldn't I? Well, I could say, all right, well, what's not going to be 1? Well, it's going to be a 2, it's going to be a 3, it's going to be a 4, it's going to be a 5, it's going to be a 6. So I've just counted, well, 5 different probabilities. Well, sorry, 5 different events, thus giving me a probability of 5 over 6. Now, we can do this even quicker because we can say that my probability of rolling a 1 plus my probability of rolling anything else or not 1 gives me a probability of 1. Now, why? Well, if I add, like I added the probabilities up here, if I add my probability of rolling a 1 plus my probability of rolling every other event that's not 1, this equation here just is composed of every single outcome, every single possible outcome, because we have my 1 and we have my 2, 3, 4, 5, 6. So it would make sense that summing complementary probabilities gives us every single thing that could happen, a certainty, a probability of 1. So we can actually rearrange my equation in an almost algebraic way. Well, we can say then that my probability of rolling not 1 is the same as my certainty minus my probability of rolling a 1. Now, let's actually put some numbers here. My probability of not 1 would be the difference between a certainty and a probability of rolling a 1, which is exactly the same as that complementary angle idea. We said that, okay, I know 1. How do I find the other? Well, I know they add up to 90 degrees. So that other unknown 1 is the difference between 90 degrees, the maximum angle sum this can be for a right angle, the difference between 90 and the angle I know. The same thing happens with probabilities. And you'll see that here we get 5 over 6. Because 1 is the same as writing 6 over 6. So the fraction of 6 over 6 minus 1 over 6 gives us our 5 over 6. This is the essence of complementary probabilities. And we can do this with anything. We can say, all right, well, I looked in the previous video, I mentioned the probability of it being odd was 3/6. So therefore, the probability of rolling an even number would also be 3/6, because that's every other event that can happen. And we know that when we roll a die, our results are going to be odd or even numbers. So I can once again lay this out as an equation where I can say, okay, say I hadn't counted this in the same way I did before, but let's say I only knew my odd probability. But I know that the probability of getting an odd number plus the probability of getting an even number is all of my possible events that can happen. We get 1 here. Now, we can do the exact same thing. I can say, well, my probability of finding an even would be the difference between a certainty and the probability of an odd number, which we get 1 minus 3/6, which gives us also 3/6, or a half chance, which makes sense from what we did in our previous video. Now, I'll leave you with that because I know we've talked about a lot, but the most important thing to note here is that, and I'll actually write it down to really stress what I'm talking about here. And this is the fact that all possible probabilities, P's, I'll just write for probabilities, sum up to 1. Because taking a fraction, all of our fractions, all of our kind of fractions of the total outcome, the certainty, all of these will sum up to 1, because adding them up is like saying all of these probabilities are inclusive. So the summing up the probability of a head and a probability of a tail is like summing up every possible event that can happen. And that makes sense that it would equal 1, because a 1 tells us for certain that this will happen. So we can say certainly, we know for certain that rolling a die will give us 1, 2, 3, 4, 5, or 6. We know that flipping a tail will give us a head or a tail. And once we know that all possible probabilities can sum up to 1, we can lay out these types of equations for calculating complementary probabilities. Because the probability of something being even here is the same as just saying the probability that it is not odd. Same thing here. These are complementary probabilities. Think of it as that word not. I have one probability here. Its complementary probability will be not that probability. So the complementary probability to a 1 would be not a 1. The complementary probability to a 4 will be not a 4. It's just every other possible thing that could happen, every other possible event. So that's all for complementary probabilities, and I'll see you guys in the next video.